problem that happens from time to time is you want to use a button or a switch or some device to send your physical computer information that's supposed to influence what it's doing. And you want that information to be incorporated into what it's doing as fast as it possibly can. The problem is, if you're relying on things like digital reads or analog reads to get information into your sketch, to get data into your sketch, there can be a significant lag between the time the external conditions change, or the state of the button changes, or the state of the switch changes, and the time that you actually get to the point in your sketch where that digital read or analog read is done. There can be a huge lag time. Some of you experienced this when you were writing your eCandle sketches. So what can you do? Well, one thing you can do is you could just do your digital reads or analog reads more often in your sketch, but that can get cumbersome and may not actually be that useful anyways. So another approach is to use what are called hardware interrupts. So it turns out that the Arduino Uno, the microcontroller on the Uno, has two pins, pin 2 and 3, to which you can attach what are called interrupts. And when the state of those pins changes, those pins essentially are acting like inputs, digital inputs. And when the state of those pins change, that is a cue to your sketch to stop whatever it's doing and to execute a snippet of code called an interrupt service routine, which takes the form of a little standalone function. And that function will be executed. And then when that's done, you return to your sketch wherever you were and pick up where you left off. So these are called interrupts, hardware interrupts. And so what I'm going to do is I built a circuit. I'll show you what the circuit looks like, and then I'll show you the sketch that I wrote to use the circuit. So the circuit is composed of a push-button switch, and that push-button switch is supposed to control the state of a relay, to turn that relay on or off. All right, so let's get started. So this circuit is a little messy little thing. I got lots of long wires, but here's the push button switch, and it's connected to a pull-up resistor. So this resistor is connected to 5 volts on one side, and then it's connected to ground through the switch on the other side. So when the switch is open, a digital read on the yellow wire here, which is connected to pin 3, would register high, 5 volts. And when the button is switched, that shorts this wire to ground, and a digital read on pin 3 would yield 0 volts. Okay, so we have a pull-up resistor connected to a momentarily on pull-up push button switch over here, and then we've got a relay over here, which is going to be controlled by digital input output pin 8 via this white wire right here. All right, so let me show you the sketch. So here it is. This is the sketch that's going to control our circuit here. And let's go through it line by line. I got I declared a variable relay pin of type byte, set it equal to 8. That's going to be the pin that's going to control my relay, turn it on and off. I've declared a variable called interrupt pin and of type byte, and it's set to pin 3, which is one of the pins that can be have an interrupt, a hardware interrupt attached to it. All right, and I'm going to skip through these for a second and just go down here. And so in the setup function, I'm setting the pin mode of the relay pin as an output. It's because it's going to turn on and off this relay. So it needs to be able to source current. All right, and then the next line is using the function, which I talked about in the handout, attach interrupt. And so I'm going to attach that interrupt to the interrupt pin, and this function, which is inside the attach interrupt function, is digital pin to interrupt. It translates the digital pin number to the interrupt number. Then the next argument in this function, IRQ, is the name of the function which corresponds to our interrupt service routine. Maybe I should have called it ISR instead for interrupt service routine, but it can be called anything. It's just a function name that's going to be run when the interrupt gets tripped. And then this is the mode of the interrupt. It specifies the condition at which the interrupt will be tripped. So I want the interrupt to be tripped when the voltage goes low on the interrupt pin, which is pin 3. All right, my loop is empty. There's nothing there. All right, everything else is handled in my interrupt service routine function. So if I go down here, we're going to skip the first 2 lines, 3 lines for a second, and just look and see what's happening in here. So what I'm doing is I have this Boolean variable called relay state. And if the relay state is false, that means the relay is off. What I want to do, if that's true, if the relay state is false, is to turn on the relay, to set the relay pin high. If, on the other hand, the relay state is true, I want to turn the relay off and then update the variable relay state to false so I know that it's off. So this if-else statement is what's going to accomplish turning the relay on and off. All right, so well, what about the rest of this stuff? I have this variable, which up here you'll see is defined as, this is the first time we've seen a variable of this data type. I'm declaring it as an unsigned long. An unsigned long can store numbers into the billions. And why do I need to be able to store numbers so large? Well, down here, this function millis is, it returns how many milliseconds since the microcontroller has been turned on. So I'm going to record, it's sort of like a timestamp. When the button is pressed, I want to record the time that occurred from the time the microcontroller was turned on, which would be the 0 on the timeline. And then what I'm doing here is I'm checking to see if the time the button was pressed compared to the last time it was pressed is greater than 500 milliseconds. And if that's true, then I go through this business of turning the relay on or off. And you might be like, well, why am I doing that? Well, there's this thing that happens when you're using interrupts. The interrupt can be triggered multiple times very quickly because when I press the button to trip the interrupt, which is going to pull the voltage low on digital pin 3, and that's going to trip this interrupt, the voltage can fluctuate very quickly, very rapidly in a short amount of time while that button is changing state. And so that can actually trip the interrupt service routine, cause the interrupt service routine, this function that gets run when the interrupt happens, to happen many times very quickly. I don't want that to happen. So what I'm doing here, some people call it debouncing or something like that. I'm just allowing a certain amount of time to pass before the interrupt service routine, the meat of it here, which involves turning the relay on and off, gets done again. Okay, and I'm waiting 500 milliseconds before I allow that to happen. All right, so that might take a little bit of time to digest, but I'll post this this sketch for you guys to study from a little bit more. All right, but just to summarize this one more time, the essence of what's going on here is I've attached an interrupt to digital pin 3, which is the value of this variable interrupt pin. And so when the voltage at that pin goes low, which is going to happen when I press the push button, the interrupt will be tripped, and that will stop the flow of the sketch and bring us down here and execute the interrupt service routine function, which is going to change the state of the relay. So if it's on, it'll turn it off, and if it's off, it'll turn it on. All right. Okay, here we go. Here's the circuit in action. So when I press the push button switch, the voltage on pin 3 is going to go low. That will trip the interrupt, which will then execute the interrupt service routine, which will energize the relay, closing the switch in the relay. And the light comes on. If I press it again, now that the relay is active, if I press it again, the interrupt service routine will have the effect of turning off the relay. That's it. So now I can build systems where a push button or a switch being monitored by the Arduino can control a relay, which is then in turn controlling a device that's actually plugged into a wall outlet, 120 volts. All right, so that's it for this lesson and this project, and I'll see you next time.